Hello? Teaching this is very difficult. Yes.
Email आपण देऊ शकतो.
Good evening, sir.
Good evening. Yeah. So let us learn about the shifting of the fringes in the interference pattern. Why there will be a shifting of fringe pattern in Young's double slit experiment? Yeah. Look at this. If I place, this is the screen. This is the source. From the source, the two light waves are traveling. Two light waves are traveling like this. At this particular point, the interference is going to take place. Interference is going to take place. Suppose in one of the ray, if I place some slab, if I place some slab in front of one of the ray, Ajay, the ray which has entered this slab will slow down. Correct, no?
Yes, sir.
If I say this is one ray and this is the second ray, if I place one slab over here, the speed will decrease. Because of that reason, it will not form here. There will be somewhere here. There will be somewhere here. So because of this reason, the fringes is going to shift either upward or downward. How that fringes shifting is going to take place. Now look at this diagram, Ajay. There are two current sources, S1 and S2. In this, we are going to place one slab of thickness T and refractive index mu. At this particular point, the interference has obtained. In the absence of this slab, the interference may obtain here. Because of this slab, the interference is shifted to this particular point. This is shifted to that particular point. To find this shift distance, we have a formula. What is that fringe shift formula? Capital D by small d into mu minus 1 into T. What is the fringe shift formula? Capital D by small d into mu minus 1 into T. What is T? Thickness of the slab. What is mu? Refractive index. Capital D is the distance between the slit and the screen. Small d is the distance between the two slits. Or you can also write the same formula in terms of beta by lambda into mu minus 1 into T, because beta is nothing but lambda capital D by small d. So what is capital D by small d from this equation? It is beta by lambda. So capital D by small d can be replaced as beta by lambda. So you can remember these two formulas to find this shift. If you want to find how many number of fringes are shifted, if you want to find the number of fringes shifted, how to find out the number of fringes shifted? The number of fringes shifted is given by the formula mu minus 1 into T divided by lambda. Mu minus 1 into T divided by lambda. If you want to find the number of fringes shift, the number of fringes shift is equal to mu minus 1 into T divided by lambda. You got my point?
Yes, sir.
Yeah. But remember, by placing the thickness of the slab only you can shift the fringes. If you change lambda, if you change capital D, if you change small d, the fringe will not shift. So shift does not dependent on the wavelength, or it is not dependent on the order of the fringe. If you want to shift the fringes, you have to place the slab in front of one of the rays. You have to place in front of one of the rays. Then only the shift is going to get shifted. If you want to find what is the shift in the fringes, you use the formula capital D by small d into mu minus 1 into T. If you want to find the number of fringes shifted, you can find that by using the formula mu minus 1 into T divided by the lambda. Divided by the lambda. So this is the shifting concept in the Young's double slit experiment. Now, Doppler effect. Don't get confused. In the first year also you have studied the Doppler effect, but that is with respect to sound. Now we are going to talk about with respect to what? Light.
Sir, light, sir.
Yeah. Now in this symbol I am going to use nu. Nu is the actual frequency. Nu dash is the apparent frequency which is going to change. V is the speed of the source with respect to stationary observer. C is the speed of light. Speed of light. Now let us take up the first case. You can observe the first case. Source of light is moving towards what? Stationary observer. Observer is at rest. Source is moving towards the observer. Then the apparent frequency is given by nu into 1 plus V by C. But apparent wavelength will be lambda into 1 minus nu by C. Please remember, you know that the frequency and wavelength are inversely proportional, right?
Yes, sir.
If frequency increases, the wavelength has to decrease. So only we are taking minus for lambda, frequency for positive. So when the source of light is moving towards the stationary observer, what is the apparent frequency formula? Nu into 1 plus V by C. Apparent wavelength will be lambda dash is equal to lambda into 1 minus nu by C. Just reverse it. If the source is moving away from the observer, so in this first case, since wavelength is going to be subtracted, you are going to get the apparent wavelength as less than the actual wavelength. Actual wavelength kinta kadame agate apparent wavelength. In the second case, apparent wavelength should be more than what? Actual wavelength. Since the apparent wavelength is less, all the rays are going to shift towards the red end. That is what we call as the red shift. In this case, it will shift towards the violet end. That is what we called as the violet shift. If you want to find what is the change in the wavelength, you can use the formula lambda into B by C. This is lambda into B by C. Change in shift is going to be the same in both the case. Lambda into V by C. Lambda into V by C. So these are the formulas in the case of the Doppler shift, in the case of an interference of light. Yeah. So before going to diffraction, let me take up the problems on interference. After completing the problems on interference, I will take up diffraction and polarization, Ajay.
Yes, sir.
Look at the first problem.
Yes, sir. Two light waves having same frequency have intensity ratio 4:1 and they interfere. The ratio of maximum to minimum intensity in the pattern will be.
If intensity ratio is 4/1, can you tell me amplitude ratio? 2/1, no?
Yes, sir.
Because intensity is directly proportional to square of the amplitude.
Yes, sir.
Our amplitude is directly proportional to root of
Square
intensity.
root of intensity.
Now they are asking you to find maximum intensity to the
So minimum intensity.
minimum intensity. That is A plus B divided by A minus B whole square, no?
Yes, sir.
Maximum intensity is square of the amplitude, A plus B whole square. Minimum intensity means A minus B whole square.
Yes, sir. So it's 9:1, sir. Option A.
So A plus B means 2 plus 1 by 2 minus 1 whole square. That is 3/1 whole square. What is 3/1 whole square?
9:1.
Yeah, good. 9:1 apart. Good. So which is the right option?
Option A, sir.
Option A. 9:1. Come to the second problem. Very important. So many times they have repeated this question in your competitive thing. In Young's double slit experiment, they are using first wavelength 5898 angstrom. How many fringes he had seen? 92. Suppose if this wavelength is shifted 5461, then how many fringes is going to be obtained? Now you know the formula to find the number of fringes I have given in the synopsis. N1 lambda 1 should be equal to what?
N2
Sir,
lambda.
into lambda 2.
Yeah. First fringe. What is the first fringe number? 92. Wavelength is 5898. N2 you have to find for which wavelength? 5461.
5461, sir.
What is into 92 into 5898 divided by 5461? Correct? No. Now, don't go
Yes,
for the
sir.
accurate calculation. Can you tell me 5898 divided by 461 will be more than 1 or less than 1? If I divide
More than
5898 divided
So
by
more than 1, sir.
5461,
So
will I
more
get
than 1.
more than 1 or less than 1?
More than 1, sir.
If this value is more than 1, if I multiply more than one value with 92, number should be more than 92 or less than 92.
More than 92, sir.
So more than
So
1.
obviously 62 is ruled out, 67 is ruled out, 85 is ruled out. Definitely you should get what? More than 92, only
So
one
more
option
than
is
92.
here.
Yes, sir.
So if you do it in the calculator also, you'll get the same thing. But have a concept, do the mind calculation, do it fast. So it should be at 99. You got it? No, how I guessed.
Yes, sir.
Yeah.
Yes, sir.
You try the third one. You try the third one. How many intensities we have?
2
Sir,
intensity.
2 intensity.
This is I1. This is I2. They are expecting the phase is pi by 2 for the first case. And the phase is pi for the second case. They are asking to find the difference between the resultant intensity at A and the resultant intensity at B. What is the formula we have to find the resultant intensity? It is I1 plus I2 plus 2 times of root I1 I2 into cos phi. Resultant intensity is given by the formula I1 plus I2 plus 2 times of root I1 I2 cos phi. Now let me calculate the resultant intensity. Let me calculate the resultant intensity for the first case. For the first case, what is the intensity? I1, I. What about second intensity? 4I plus 2 into root of I1 I2 means I into 4I cos pi by 2.
Cos pi by 2.
What is cos pi by 2?
Cos pi by 2. What is cos
So
pi by
0.
2?
So IR1 will be equal to 5I. So this is the first resultant intensity. Similarly, you calculate what is IR2. IR2 should be calculated for which phase angle?
So pi.
Yeah, you calculate the second intensity, resultant intensity you should calculate and you take the difference. After finding IR2, you find out what is the difference.
So is the difference 2I,
What
sir?
is cos pi?
So -1.
So
Yeah, after substituting -1, you will get what?
So 5i minus
I,
4. Sir.
yeah, -4. So how much you'll get?
So
4i.
sir.
No, plus 4i minus 4i will get cancelled.
Sir,
No,
I, sir, I,
But take the difference.
yes, sir. So it's 4i, sir.
Yeah. So the second option is going to be correct. Yeah. Look at the fourth question. How many waves they have represented? 2 waves. Y1 4a sin omega t. What is this 4 represents? Amplitude. What is the second amplitude? 3. What is the phase difference between these 2 waves? What is the phase difference?
Pi by 3.
Pi by 3. They're asking you to find the amplitude of the resultant wave. What is the resultant amplitude wave formula? Root of a squared plus b squared plus 2ab into what? Cos phi.
So cos phi.
Yeah, substitute a value, b value and phi value. You simplify, approximately will get 6. Do the calculation fast.
So yes, sir, 6, sir.
Yeah, you will get approximately 6 because it is root 37, which is close to 6. Got it, Dhanlakshmi?
Yes, sir.
Yeah. Yes. Come to this. How many waves are taking place here? 2 waves
2
from
waves.
S1 and S2. They're having 0 phase difference. Phase difference is 0 means, can you tell me the corresponding wavelength it has? Lambda. Okay.
Yes, sir.
If the phase angle is 0, can you tell me what type of interference is going to take place? Constructive, no?
Yes, sir.
Because for constructive interference, phase difference should be like 0, 2 pi, 4 pi, like that. Path difference should be like 0, lambda, 2 lambda, like that. Now they are expecting what type of interference?
Destructive.
For destructive interference, 5 lambda is not possible. 2 lambda is not possible because 2 lambda and 5 lambda will be in this format. So constructive interference will take place. And 3 by 4 lambda is not at all possible because 3 by 4 lambda is less than lambda. Which is less than that, no.
Yes, sir.
So this is also not possible. So option is which one? Eleven by 2 lambda.
Yes, sir. So option D.
Yeah, because for destructive interference, what is the condition for path? Lambda by 2, 3 lambda by 2, 5 lambda by 2, 7 lambda by 2, like that. So you can get 11 times of lambda by 2. Okay. How many interfering waves we have? Two interfering waves. First intensity is 9I. Second intensity is 4I. What is the path difference they have given? 11 lambda. What is the resultant intensity? You know the relation between phase difference and path difference? Phase difference is equal to 2 pi by lambda into
X.
path difference.
Path difference, sir.
Phase difference is equal to 2 pi by lambda into path difference. What is the path difference they have given? (11 lambda). So lambda will get cancelled out. 11 2s are 22 pi. I mean phase difference. So what is the phase difference?
22 pi.
22 pi. Now what is the formula we have to find the resultant intensity? I1 plus I2 plus 2 root I1 I2 into what?
Cos pi.
Cos pi. So this is 9I plus 4I plus 2 root 9I into 4I cos 22 pi. Cos 22 pi. You know the value of cos n pi, right?
Yes,
It
sir.
is -1 whole power n. Cos n pi value is -1 whole power n. What is cos 22 pi? -1 whole power
N
22.
all power 22.
So it is +1 or -1?
+1.
So this value is +1. You can simplify further now. 9I plus 4I will be 39. 9 4s are 36. Root 36 will be 6. 6 into 2 will be 12I. Because cos 22 pi
So
value will be
25i.
+1. So 39 plus 12I.
25i.
So option D is the right answer. Yeah. I think it's very quite simple. Maximum intensity and minimum intensity is given. I max by I minimum. You know I max is A plus B. I minimum is A minus B whole square. From this, what is A plus B by A minus B? Root of I max by I minimum. That is root of 144 by 81. Root 144 is 12. 81 will be 9. You can find what is A by B. Just have a look. You can do the reverse calculation. Sum of two numbers should be 12. Difference of two numbers should be 9. So on inspection method, you can take A as no. You do one thing, do the cross multiplication. 9A plus 9B is equal to 12A minus 12B. You find what is A by B from this?
So 3A and 21B.
So 12A minus 9A is 3A is equal to 12B plus 9B. No,
Yes, sir.
21B. So what is A by B?
Sir,
3 by 21. What is 3 by
21.
yes,
21?
sir. So 1 by 7. Option C, sir.
1 by 7, right?
Yes, sir.
Yes, sir.
Option C. Okay. Come to this. How many interfering waves we have? 2. Intensity is given. This is I1, X. I2 is Y. With the time difference. What is time difference?
3T by 2.
3T by 2. Time difference. What will be the resultant intensity? What will be the resultant intensity for 3 times of 1 by 2? Now let me take one wave. Correct, no?
Yes, sir.
This time is called one wave, right?
Yes, sir.
Half of that,
T by 2.
next off.
Sir,
T
T
by
by
2.
2.
Yeah. To get 3T by 2, it is 1.5 wave, right? This is T by 2. This is T by 2. This is T by 2. So this total value will be 3T by 2, isn't it?
Yes, sir.
So this is 0. This is pi. This is 2 pi. This is 3 pi. So what is the corresponding phase angle for 3T by 2? What is the corresponding phase angle for 3T by 2? 3 pi. Correct, no? So for this time difference, phase is 3 pi. Phase is 3 pi. Now tell me the resultant intensity formula. Tell me the resultant intensity formula. I1 plus I2
1 plus I2 plus 2 root of I1 I2
Sir,
cos
I want
into
cos pi.
cos phi.
the cos pi.
Now, if the phase angle is 3 pi, it is a constructive or a destructive interference.
Constructive, sir.
It is a constructive interference. You simplify for the resultant intensity. You find what is the resultant intensity by substituting that. What is I1?
X, sir.
What is X2?
Y, sir.
Plus 2 root XY.
XY.
Since it is a constructive interference, cos phi should take maximum value. So our cos 3 pi value will be equal to what? Cos 3 pi value.
-1.
So x plus y minus 2 root xy. This will be the intensity at 3 pi. Option C. Option C. X plus y x plus y minus 2 root xy. Option C. Got it?
Yes, sir.
Look at the next problem. So look at the next problem. In Young's double slit experiment, screen is obtained what wavelength? 6000 angstrom from the two coherent sources S1 and S2. Which fringe is formed?
Third dark fringe.
Third dark fringe is formed. What is the condition for the path difference? For destructive interference? 2n minus 1 into what? Lambda by 2. This is the condition for the destructive interference. For third dark fringe is asking n equals to 3. So 2 into 3 minus 1, lambda is 6000 divided by the 2. 2 into 3 is 6. 6 minus 1 is 5. 5 by 2 into 6000. 6000 by 2 will be 3000. 3000 into 5. How much?
So
So 6000 by 2 is 3000. No, 3000 into 5.
So 15,000, sir.
15,000 into 10 power minus 2. I mean minus 10. But they are expecting the answer in microns. So 15,000 can be taken as 1.5 into 10 power.
So -6.
So in micron, it is option D. 1.5 into 10 power minus 6. Yeah. In Young's double slit experiment, slit separation is 1 mm. Screen is placed at 1 meter. Monochromatic wavelength is 500 nanometer. They are asking to find the distance of the third minima. Third minimum is third dark. What is the distance of the dark band? 2n minus 1 lambda capital D by what? 2D. Now you simplify this. What is n value? 3 minus 1. Lambda is 500 nano. Capital D is 1. Small d is 1 milli. Simplify this.
Hey. Hey. Two into 3 is how much? 6. 6 minus 1 is 5. 5 into 500 into 10 power minus 9 by 2 into 10 power minus 3. So 5 into 500 will be 1000, 2500. 2500 by 2 will be 1250 into 10 power minus 6. So 1250 into 10 power minus 6 can also be taken as what?
1.25 millimeter.
Yeah, 1.25 millimeter. So option B. Yeah, come to the next problem. Yesterday I have given the int. Yesterday I have given the int for this. Two slits are separated by what distance? 1 millimeter.
So 1 millimeter.
What about the wavelength?
So 6.5 into 10 to the power of minus 7.
They're expecting you to find, interference is obtained on the screen at a distance. Capital D is 1 meter. Distance between the third dark and the fifth bright. So they're expecting you find the distance of the fifth bright and third dark. So nth bright band, what is n? 5. Mth is for dark.
M 3. So to find the distance between this, you know that n is more than m. You can find that by using the formula n minus m plus 1 by 2 into beta. You simplify this. You know beta is nothing but lambda capital D by small d, no? Yeah. This is one generalized formula. You substitute and tell me the final value. How much you got? Or also you can find distance of the fifth brand separately by using formula n lambda capital D by small d. If you want third dark, 2n minus 1 lambda capital D by d. Since here n is fifth bright band, 5 lambda capital D by small d, n is 3, 2 into 3 is 6, 6 minus 1. It is 2d, right? So 2 into 3
Yes,
6,
sir.
6 minus 1. 5 lambda, 5 by 2, that is 2.5 lambda capital D by d. If you want to take the difference, you will get 5 minus 2.5, that will be 2.5 lambda capital D by 2. Here also you will get the same thing, I think. 5 minus 3, 2 plus half. 2 plus half is 2.5 only, no? Lambda capital D by small d. So it is 2.5 lambda capital D by small d. Substitute lambda capital D and small d, how much you will get? Check once. Will you get 1.63 millimeter or not?
Yes, sir.
You can do in either the method, appa. If you don't forget, if you don't remember this standard formula, you can use x5b first, then x3d second, then take the difference. You will get 2.5 lambda only. 5 lambda capital D by small d minus 2.5 lambda capital D by small d. You will get the same thing. So finally you will get 1.63 millimeter. You try this. You try the 12th one. I have explained in the synopsis.
ಹಾಸ್ಪಿಟಲ್ ಹೋಗಿ ಇಂಜೆಕ್ಷನ್ ಬಂದೆ ನಾನು ಕಡಿಮೆ ಆಗಿದೆ ಒಂದು 5 ನಿಮಿಷ ಕಾಲ್ ಮಾಡ್ತೀನಿ ಆನ್ಲೈನ್ ಕ್ಲಾಸಲ್ಲಿ ಏನು 5 ನಿಮಿಷ What is the intensity at the central fringe? I naught. If one of the slit is closed, what will happen to the intensity? Look at the concept here. You know intensity is directly proportional to square of the amplitude. Intensity is square of the amplitude, no?
Yes, sir. Directly proportional to square of amplitude.
Yeah. Now, if among these two slits, if one slit is closed, half of the amplitude is decreased, no?
Yes, sir.
So for this, complete wave is coming like this. The waves are coming like this. This is the amplitude. If half of the slit is closed, I'm going to get only this slit, only of this portion. So what happens to the amplitude? If I say this is A, this will become A by 2.
A by 2, sir.
So what will happen to the new intensity? A by 2 squared. A squared by 4. So I dash is equal to A squared is I by 4. So new intensity will become original intensity by how much? Original intensity divided by how much?
Sir.
4.
So 4, sir.
So remember, when one of the slit is closed, the amplitude will reduce us to half times. So the intensity becomes I naught by 4. Got it?
Yes, sir.
Okay, pa. I will stop at this stage. We'll continue in the next class from 13th problem. So in the next class, I can finish off the problems on interference. Then immediately we'll take up the diffraction and polarization. Okay?
Yes, sir.
Yeah, pa. Thank you.